Okay everybody, welcome back to Precalculus. Today we're going to be going over 1.6, which tackles the topics of parent functions, which are like the base versions of functions without any transformations or anything being done onto them. So there are a couple of functions that you do need to know about, so we're going to go over those, and the first one we're going to get into is the linear function. So the linear functions can be represented by f of x equals ax plus b, or by y equals mx plus b. They both mean the same thing. It's just replacing y with f of x and replacing m for a. The slope is m if you're using y equals mx plus b. If you're using f of x equals ax plus b, your slope is going to be a, and the graph is going to look constant if m or a equals 0. The y-intercept is going to be found through y equals 0, b. The domain is going to be all real numbers, which you can represent with that capital R with a line going straight down it. You can also represent it in interval notation by saying negative infinity to infinity. The range is also all real numbers. The graph has an x-intercept of negative b over m, 0. The graph is increasing if m is greater than 0, decreasing if m is less than 0, and constant if m equals 0. And as you can see to the right here, I've got a basic y equals mx plus b graph here. It looks like the slope is 1, and it just looks like a straight diagonal line. So then we get to the squaring function. So the squaring function can be represented through f of x equals x squared, and it's going to look like a u-shaped curve, as you can see on the graph to the right. The domain is going to be all real numbers, and so is the range. It's also going to be all real numbers. This function is even, meaning that if you plugged in negative x for x, you would just get f of x in return. It has an intercept at 0, 0. The graph is decreasing on the interval at negative infinity, 0, and increasing on the interval 0, infinity. This graph is symmetric with the y-axis, and it has a relative minimum at 0, 0. And as you can see, we've got another depiction of f of x equals x squared here. You can see the u-shaped curve, you can see the symmetry about the y-axis, you can see the relative minimum at 0, 0. Next we get into the cubing function, which can be represented by f of x equals x cubed. The domain and range are all real numbers. This function is odd, meaning that if you plug in negative x for x, you're going to get negative f of x out of it. It has an intercept at 0, 0. It's increasing on the interval negative infinity, infinity, and it's symmetric about the origin. So here to the upper right, you can see the graph of x cubed. You can see that it's always increasing, and you can see the intercept is 0, 0. You can see how it's symmetric about the origin. If we have an x, y point here, we're going to have a negative x, negative y point right here. And then we get into the square root function after that, which can be represented by f of x equals square root of x. The domain is all real numbers greater than or equal to 0, which can be represented with a closed bracket, closed bracket 0, infinity, meaning that you can plug in 0. It is inclusive to 0, but nothing less than 0. You can't plug in negative 0.1 or negative 5 or negative 100, because you would get a negative answer in the square root, which would be an imaginary number. Then the range is also going to be all real numbers greater than or equal to 0. It's going to have an intercept of 0, 0, and the graph is increasing on the interval 0, infinity. So you can see from this graph on the lower right hand corner that it's increasing from 0 to infinity. The domain, which is all the x values that you can plug into the graph, starts at 0 and goes to infinity, and the same thing for the range. The range is all the y values you can plug in, or the y values you can get out, and you can see it starts at 0 and goes up to infinity, and you can see the intercept at 0, 0. Now we get into reciprocal functions, which are also called hyperbolas. These are going to be represented through f of x equals 1 over x. The domain of the function is negative infinity, 0, union 0, infinity. The range of the function is negative infinity, 0, union 0, infinity, where union just means and. It means like negative infinity, 0, and 0, infinity. The function is symmetric about the origin, and the graph has no intercepts. So as you can see from this hyperbola here, the graph never intersects with any of the axes. You can see that the domain and range are negative infinity to 0 and 0 to infinity, but it will never be at 0. That's why it's open brackets around the 0, because if you were to plug in 0 for x, you'd get 1 over 0, which is undefined. So then we get to the absolute value function, which is represented by f of x equals the absolute value of x. But now it's important to know the definition of what an absolute value is. An absolute value can be defined piecewise. So if we redefined absolute value of x so that it was a piecewise defined function, we would see that f of x is equal to x when x is greater than or equal to 0, and f of x is equal to negative x when x is less than 0. And the reason that is because whenever you have a negative number in the absolute value brackets, it's going to make it positive. So if we plug in an answer like negative 5, for example, and we plugged it into the absolute value function, we would get positive 5. And if we plug negative 5 into our piecewise defined function, which means the same thing, then we would get negative 5, which is positive 5. So they're the same thing. It has intercepts at 0, 0. It's symmetric about the y-axis. The domain is all real numbers. The range is all real numbers greater than or equal to 0. X and y intercepts at 0, 0, like I said, and it's increasing on 0 to infinity. And it would be decreasing on negative infinity to 0. So as you can see here, it's decreasing from negative infinity to 0, increasing from 0 to infinity. You can see that the range is all real numbers greater than or equal to 0, and you can see that it is symmetric about the y-axis. So then the last function we're going to talk about is the step function. The step function is can be represented by f of x equals this double bracket shape x, and what that means is the greatest integer less than or equal to 0. So it's important to know what an integer is. An integer is like 1, 2, 3, negative 1, negative 2, negative 3. A decimal number or a fraction that is not a whole number can't be an integer. So 13 over 8 is not an integer. 5.48567 is not an integer either. So that's what we mean when we talk about greatest integer less than or equal to x. The domain is all real numbers. The range is all integers, which is represented by this shape that looks like a Z. And it's basically a Z, but then you have this second line coming down here to kind of make that middle band a little bit wider. It has a y-intercept of 0, 0, and an x-intercept on the interval 0, 1, including 0, but not including 1. So as you can see here from the graph on the right, it's intercepting the x-axis at 0, like it's intercepting the x-axis all the way up until 1, and then at 1 it jumps up here and it's no longer intersecting the x-axis. And then at negative 1, for example, it's also not intercepting the x-axis. The graph is constant between each pair of consecutive integers, and the graph jumps vertically 1 unit at each integer value. It's also called a rounding down function, and you may also see it get written as this like kind of almost bracket thing, but not quite bracket. So as you can see, on the left hand side you always have the closed bracket, meaning it's including that point, and then on the right hand side it's an open bracket, meaning it's not including that point, because at that point it jumps up to the next value. So those are the functions you need to know about for this unit, so let's get on to some practice problems. Okay, so in this first question we're asked to write a linear function f such that it has the indicated function values, and then to sketch a graph of the function. So we're given f of 1 equals 4 and f of 0 equals 6. So right away I know that we can find the slope because we're given an x1 and an x2 and a y1 and a y2. So what I'm going to do is I'm going to say m equals y2 minus y1, y2 minus y1 over x2 minus x1. So my y2 is going to be 6, and my y1 is going to be 4, so I'm going to have 6 minus 4, and my x2 is going to be 0, and my x1 is going to be 1. So I'm going to have 6 minus 4 over 0 minus 1, which is negative 2, just 2 actually. 6 minus 4 is 2, and 0 minus 1 is negative 1, which is negative 2. So then my slope is going to be negative 2, and so if I write this in y equals mx plus b format, y equals mx plus b format, I'm going to have y equals negative 2x plus b. And I need to find b, which is my y-intercept. But if you remember from our definition of our y-intercept, a y-intercept is 0, b. Meaning our y-intercept is wherever x equals 0. And right here, we're given that when x equals 0, y equals 6. Meaning our y-intercept is 6. So our equation is going to be negative 2x plus 6. And then when I go to sketch a rough graph of this, I can draw my axes like this. And I'm going to go up 6 points like this, and I'm going to make my x-axis over here. So 1, 2, 3, 4, 5, 6 right here. Our y-intercept is at 6, and it has a slope of negative 2, meaning we're going to move down 2 over 1. Down 2 over 1. Down 2 over 1. Right there. And it would continue to go down like this. But I'm just doing a rough sketch, so I'm not going to graph all the points, but that's how you do that one. Alright, so in this next question we're asked to do the same thing, except now we're given f of 5 equals negative 4 and f of negative 2 equals 17. So I want you to pause this video, try it on your own, and then come back to it when you think you have the right answer. So assuming you pause the video and tried it on your own, let's see how you did. So once again, we're given an x1, a y1, an x2, and a y2. So we're going to go ahead and find the slope first. So I'm going to write m equals y2, which is 17, minus negative 4, which is y1, and then negative 2 minus negative 4. Oh, sorry. Negative 2 minus 5. That's our x2 and x1. So minus negative 4 is the same thing as addition, like that. So we have 17 plus 4, which is 21. And then we have negative 2 minus 5, which is negative 7, like that. And then 21 divided by negative 7 is negative 3. So our slope is negative 3. And so now we have y equals negative 3x plus b. So now we want to find out what our b value is. So we can plug in any x or y ordered pair for this, and then we could just solve for b. So we could plug in negative 2 and 17, or we can plug in 5, negative 4. I'm going to do 5 and negative 4 just because those are easier numbers to work with. So I'm going to have negative 4 equals negative 3 times 5 plus b. So that's going to give me negative 4 equals negative 15 plus b. And then I'm going to add 15 to both sides and get b equals 9. So my equation is going to be y equals negative 3x plus 9. So if I was to graph this out like this, and I set it up like this, and I go up 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. That's where our y-intercept is going to be. And then I'm going to go down 3 over 1, down 3 over 1, and then 1, 2, down 3 over 1. My graph is going to look like this. So that's how you do that one. Okay, so a quick correction. 15 minus 4, I made a mistake there. It's actually 11, not 9. So this is negative 3x plus 11, like that. So it would look similar to this, it's just that your y-intercept would be 11 instead of 9, and you'd still go down 3 over 1, down 3 over 1, just from the point 0, 0, 11 instead of 0, 9. So that's how you do that one. So in this next question we are asked to do the exact same thing, except this time the numbers we're given are f of negative 5 equals negative 1, and f of 5 equals negative 1. So once again I'm going to start off by just finding the slope. So I'm going to do m equals y2 minus y1, so negative 1 minus negative 1 over 5 minus negative 5. So minus and negative is the same thing as addition, so we're going to be left with negative 1 plus 1 on the top and 5 plus 5 on the bottom. So that's going to give me 0 over 10, which is just 0. So that means our slope is constant. So we know that if our slope is constant, then it's going to look like a horizontal line. So I can write this as y equals 0x plus b, and 0 times x is just 0, so I'm going to write it as y equals b. So whatever our b value is our y value. And we can see that in both points that were given, negative 1 is our y value, meaning b equals negative 1. Because it's a horizontal line, it will be going straight like this even as it hits the y-axis, even as it intersects the y-axis. So we draw a graph here like this, and it's going to be a horizontal line at y equals negative 1. So like this, let's call this negative 1. It would just be a horizontal line like that. And that's how you do that one. Your equation would be y equals negative 1. Okay, so in this next problem we're asked to do the exact same thing, except now we're given f of 1/2 equals negative 6 and f of 4 equals negative 3. So considering I did the last one, I want you to pause the video, try it on your own, and come back to this when you think you've finished. So assuming you finished, let's see how you did. So I'm going to start off by finding the slope. M equals negative 3 minus a negative 6 over 4 minus 1/2. Now minus a negative becomes a positive, and this becomes negative 3 plus 6, which is 3 over 8/2 minus 1/2. I did that to get them into like denominators so I could actually do the subtraction. So that's going to be 3 over 7/2, which, if you remember, dividing by a fraction is the same thing as multiplying by that fraction's reciprocal. So 3 divided by 7/2 is the same thing as 3 times 2/7, which gives us 6/7. So that's our slope. So we're going to have y equals 6/7 x plus b. And now once again I can just plug in any ordered pair that I want. I'm going to plug in 1/2 comma negative 6, just because I think that might be a little bit easier on us on the end. So I'm going to have negative 6 equals 6/7 times 1/2 plus b. I can cross reduce this. So now I have negative 6 equals 3/7 plus b. So now I can subtract by 3/7 on both sides. And I'm going to multiply this 6 by 7 in the numerator and the denominator. So I'm going to get negative 42 over 7 minus 3/7 equals b, which gives me b equals negative 45 over 7. So when I go to write my equation, it's going to be y equals 6/7 x minus 45/7. And if I were to go and graph this, I would have to make a really rough sketch because this is all in fractions, but it would be something like this, and I would go down just past -6, so 1, 2, 3, 4, 5, 6. So -6 is down here, so I would go down just past it like this maybe, and then it goes up 6, so 1, 2, 3, 4, 5, 6 like that, and then over 7. Let's just call 7 over here. This is going to be a really rough sketch. I only have 2 points. So, yeah, that's how you do that one. Okay, so in this next question we're asked to evaluate the function at the indicated values. And our function is f of x equals the greatest value integer of x. And we're told to evaluate it at f of 2.1, f of 2.9, f of -3.1, and f of 7 halves. So what we need to remember with these step functions, or these rounding down functions as they're also called, is that we want to round down with them. So f of 2.1 we're going to round down, and that would just be 2. F of 2.9 we're going to round down, and that would just be 2. F of -3.1 might seem a little bit tricky. You might want to round it to -2 because you're thinking that, oh, 2 is less than 3, so -2 is less than -3. But what we have to remember here is that on a number line, it's kind of going backwards in the negative space. So -4 is actually smaller than -3, and -2 is larger than -3 because it's closer to 0. So in this one, f of -3.1 would be -4. And then f of 7 halves is the same thing as 3.5, so we'd round that down to just 3. And that's how you do those ones. Okay, so in this next question we're once again asked the same thing, except now our function is the greatest integer value less than or equal to x plus 3. So, the values we're supposed to evaluate at are f of -2, f of 1/2, f of 4.2, and f of -21.6. So if we do f of -2, we're going to plug in -2 for x, and we're going to get -2 plus 3, which is -1, or just +1 actually, and 1 is the greatest integer value less than or equal to 1. So this one is just 1. Then for 1/2, we're going to have 1/2 plus 3, which I'm going to rewrite as 1/2 plus 6 halves. So then that's going to give us 7 halves. And this was actually part D of the last problem. And we solved this one, we said it was 3, so it's going to be 3 again. Let me write that a little bit better. Then we have 4.2, so that's going to be 4.2 plus 3. 4.2 plus 3. And then that's going to be 7.2 with our greatest integer value signs like this, and rounding down, remember, because this is the rounding down function, it's just going to be 7. Then we have -21.6, so that's going to be -21.6 plus 3. So that looks like it's going to be -18.6. And remember, we're rounding down, so this is going to, and we're in the negative space, so this is going to be -19. So that's how you do those ones. Now our function is 3x minus 1, and we're asked to evaluate it at f of 2.5, f of -3.2, f of 7/3, and f of -21/3. So in part A right here we have 3 times 2.5 minus 1. So 3 times 2.5, I'm just going to do this out long form. If you know this off the top of your head, then you can just skip this step. So 3 times 5 is 15, and then 3 times 2 is 6, plus 1 is 7. So 7.5 minus 1 is 6.5, so we're going to have 6.5, or we're going to have 7.5 minus 1. and then that's going to be 6.5. And since this is the rounding down function, we're going to be rounding down, which is going to give us an answer of 6. Now in this one we have negative 3.2 times 3. So once again I'm going to do this out the long way. So 3 times 2 is 6. 3 times 2 is 6. 3 times 3 is 9. Decimal goes here. And then we have a negative right there. So we have negative 9.6 minus 1. Negative 9.6 minus 1, which is negative 10.6. And if we're rounding down from negative 10.6, we're going to go to negative 11. So our answer is going to be negative 11. Now in this one we have 7 thirds, so it's going to be 3 times 7 thirds. 3 times 7 thirds minus 1. We can cross reduce these 3's here and just get 7 minus 1. And then 7 minus 1 is 6. And we can't round down any further from 6 because that's the integer that's less than or equal to 6. Or that's the greatest value integer that's less than or equal to 6. So our answer is just 6. And then for this one, negative 21 thirds is the same thing as negative 7. So what we really have here is 3 times negative 7 minus 1. So that's going to be negative 21 minus 1, which is negative 22. And the greatest value integer that's less than or equal to negative 22 is negative 22. So our answer is just going to be negative 22. And that would be your final answer to that one. Okay, so in this next problem we're asked to do the exact same thing, except our equation now is 3 times the greatest value integer less than or equal to x minus 2 plus 5. And so this first one we have is negative 2.7. So we're going to have 3 times negative 2.7 minus 2 plus 5. And we want to treat these rounding down function brackets almost like parentheses, meaning we're going to evaluate what's inside the parentheses first. So negative 2.7 minus 2 is negative 4.7. So we have negative 4.7 and then plus 5. And so if we round down, we're going to have 3 times negative 5. 3 times negative 5 plus 5. So we have negative 15 plus 5, which is negative 10. Now in this next one we have 3 times the greatest value integer less than or equal to negative 1 minus 2, and then plus 5. Negative 1 minus 2 is going to be 3, so we're going to have 3 times negative 3 plus 5. And now the greatest value integer less than or equal to negative 3 is just negative 3. So we're going to have 3 times negative 3 plus 5. So that's negative 9 plus 5, which is negative 4. That would be your answer for that one. Now in this next one we have 0.8. So we're going to do 3 times 0.8 minus 2 plus 5. So 3 times, and then 0.8 minus 2 is 1.2, negative 1.2. So we're going to have 3 times negative 1.2 plus 5. And so because we're rounding down, it's going to be 3 times negative 2 plus 5. So that's negative 6 plus 5, which is negative 1. And now in this last one over here, we're going to have 3 times 14.5. 14.5 minus 2. And then plus 5, which is going to get squeezed down to this next line. And so when we rewrite that, that's 3 times 14.5 minus 2 is 12.5, and then plus 5. And there is a decimal here. Now 12.5 rounded down is 12, so we have 3 times 12 plus 15, and so that's going to be 36 plus 15, or 5, I mean not 15, which is 41. So that would be your answer for that one.